So we've, oh god, we've got more DirectX. Rendering to do. So maybe we compile, yeah. So we can render rectangles. Let's see, I think there are some to-dos left. Dimensions, yeah. So as far as I know, there is no way to like just read the dimensions of the viewport. Like the GPU obviously knows how big the buffer is that it's writing to, but I'm not allowed to access that apparently. So we are gonna have to pass that in. It's just ridiculous. It's like, fine, whatever. Also, we don't really need to do this multiple times. Alright. Oops. There. Okay. So that should not change anything. Yeah, that doesn't change anything. Okay, so then yeah, let's leave that there for now. So then we need to create a constant buffer and pass in dimensions that way. Okay. D3D11 buffer, const buffer. Well, we might have more things in there than just that. Alright, so how do you do constant buffers again? Oh, it's like you need to bind it. So there's some extremely unintuitive way of doing it. Let's see. Why is it a different set of results every time? Just load all of them. It's not that hard. There it is. Win32 D3D11. Maybe I should just bookmark it. Yeah. C buffer. Yeah, there it is. Okay, so it's C buffer, register, B0. Apparently that's how you do it. Okay, well. Yeah, and then you just put the data in there. Like that. Okay, now we need to actually create it somewhere. Actually, we don't need to do this anymore. Now that we're not trying to fight the formatter, just write it normally. Yeah. Now we've got this vertex buffer here. well, it's not the vertex buffer, it's the buffer for the rectangles. Rect buffer. Let's create a constant buffer here. Okay, so it's essentially this, except we're not gonna have any initial data, and we're gonna pass in just a const buffer. Okay. What's the description of the device, of the buffer? I mean, well, byte width is going to be, well, I guess we kind of have to duplicate this struct here. Like that. So this is just const buffer size of. Dynamic usage, bind, it should be bind constant, right? Bind constant, yeah. Yeah, okay, so we've created the buffer. Now I need to write to it. So at the beginning of the frame, okay, so there's this IA set vertex buffers. Is there an equivalent for constant buffers? I think so. Set constant. Yeah, except it's gonna be VS, right? VS set constant buffers. And it's the same weird start slot number of buffers and then the pointer to the buffers that we are setting. There's no strides or offset this time. VS set constant buffers context. Yeah, it's context. Start slot, number of buffers, pointer to the first one. Start slot, buffers length, buffers pointer. Okay, so this is a setting it, but before we set it, we need to write to it. Here, I mean, I guess, why not? Yeah, why not? Okay, so to write to a buffer, you need to map it, then write to it, then unmap it. And actually, is that enough to just set the constant buffer? Or do you have to do something else? Yeah. Map, write, unmap. Yeah. So map, write, unmap. It's the so shader resource is just it's the texture. You see, constant buffer is just a buffer. So device context has a map function in it. Context LPV table map, and then there's unmap, and both of these take context. And well, we need to tell it what to map, so that's and what to unmap. D3D11 resource. So this would be a const buffer, but we need to cast it. D3D11 resource star const buffer. And okay, D3D11 map. Let's see, what are the actual arguments there? Map type. Well, that's for mapping, yeah. And there's also unmap. Well, let's figure out mapping first. Resource. That's this thing. Sub-resource. There's no sub-resource. Map type. Map right, discard, I guess. Map flags. Yeah, well, we don't really care about that. And mapped resource is the return value. Is this D3D11 mapped sub resource? D3D11 mapped sub resource. Mapped. So we pass that in. Let's see. Too few arguments. Resource, sub-resource. Map type, map flags. No, this is not a pointer. Unmap. Resource, sub-resource. What's in there? P data. Oh, P data is what we're interested in. P data. So we can write in there. And I would just write yeah, I mean, float 2, we already have a v2 here, so might as well just do that. Window width, window height. Just ridiculous. What, can you not just do that? Like it's a v2, this thing. What, I can't, do I have to do this? I mean, just like what's wrong with this? I don't understand. Following statement. What statement are you talking about? Yeah, so this is fine, but this isn't. Like, can I not have a struct literal be assigned to the thing? What? No, that's not. It's like you can do it here. Okay, well. No, that's just not allowed, huh? Why? Why not? It's the same as. Can I like construct it? Yeah. Well, this is it. Dimensions are invalid. Byte width must be a multiple of 16. Of course. I mean, how could you possibly map something that's not a multiple of 16? No one's ever done it. We just need to introduce some padding. We have 8 bytes of padding. Right. Yeah, so it's not moving anywhere. Yeah, alright. Well, that's it. Yeah, that's fine. Pass in viewport dimensions. Okay. So that's that to do. Done. Now we would like to be able to draw textured rectangles, ideally. So let's do that. So first we need to create the texture. Well, actually we need to remove this buffer. Right, yeah, live objects. Yeah. So now we need to create the texture. That we don't actually need to write to it, because the texture is going to contain just ASCII, and I'm not going to change the ASCII, so it doesn't have to be writable. Texture. And yeah, we don't really need to blend anything. Actually, do we? No, we do need to blend. Okay, well, that is the texture view, so we don't need the texture. We can release the texture now. We need the texture view though. That we do need. Alright, so for now we're just gonna have a texture like that. Okay, that's the first thing. Let's try the shaders. Texture. Well, okay, so text shader resource view is what we actually need to skip. Okay, and we create it with just create shader resource view, which is on the device. And well, it's device, then it's texture, but we need to cast it as an D3D11 resource. And and it's, what is it, sub-resource or something. Resource description, which we don't have in the reserve value. Okay, now apparently we don't need the description. And then it's texture view, and that returns an H result. Okay, so we do need that texture. And that texture comes from just create texture. Okay, so it's D3D11 texture to D. Star. Yeah, device, create texture to D. Device, well, yeah, device. Device, description, data, and texture. Device, description, data, which is initial, and texture. Come on. Okay, so that is our texture and texture view. Now the description, D3D11 texture to D desk. Texture to D, like that, desk is something. It's all these things. Alright. Width. Height. Well, for now, it's gonna be fixed like that. We're gonna change that later. Nip levels. Map levels. Well, we don't really need any of them. So 1. Array size. Number of textures in the texture array. Well, presumably 1. Format. It's just so this one's gonna be, well, we're gonna use it for the font, so it's gonna be just a single byte, so like R8 uint. Is there such a thing? Well, it's A8, of course. I think there is some gotchas involved with these alpha textures though. But let's see, so A8 uint oh, and what's the difference between that and unorm? Well, A8 unorm will do. Yeah. Yeah, we just need to make sure to use that correctly. So that's fine. A8 unorm sample desk. Count quality. Yeah, I think count 1. That's it. Usage. Unusable. Bind flags. Well, bind shader resource. CPU access flags. None of those, yeah. And misc flags. Yeah, none of those. Okay, let's compare. Width, height, nib levels, array size, format, sample usage, bind shader resource, yeah. So that's the description. Now we need the initial data, which is D3D11 sub resource data. Initial sysmem is pixels and sysmem pitch is 2. Yeah. And we're gonna have what, like byte array pixels, and it's gonna be something like 0.1, well, not 0.1, 10, 50, 100, 255, I don't know, something like that. So times the pixels. Yeah, width 2, height 2, pitch 2. That's fine. Does that compile? Nope. And how do I do a byte literal? D-long number literals. Let's see if we... Identifiers, no. Special token, no. I can't do a byte literal. Just trust me, it will fit. I mean, actually, maybe it will fit without the cast if I just pre-specify how long it is. No. Now we just need to use that. Again, there is some weird stuff we have to write in the shader to be able to access a texture. So texture 2D, float 4, texture 0, register T0. Okay. So our texture is not a float 4, but I think we still have to write a float 4 here. Otherwise it won't work. Float 4, texture 0, no, just a name. Register T0. Texture 2D. Yes, so that's how we declare it, and then we can like sample it from here. Well, kind of. Yeah, so text is sampler texture 0 sample. It's like, oh my god. Sample, and we pass a sampler and UV. And of course the language server is behind the actual no, there's no way to reload it. Amazing. Can I like open the file? Yeah. Okay, so we need the sampler thing. And that was like multiply by input color. So we also need a sampler. Sampler 0, register S0. Sampler 0. Sampler. Texture is capitalized, sampler is not. What's the... Oh. Oh yeah, so we need to actually pass in the correct UV. Yeah, which is just top left, bottom right. Text. Well. Top left. And then text bot right. Text bot right, like that. So this is going to be a font texture, so we're going to be specifying this in pixels. Okay, well, so that's going to be interesting. I mean, we kind of need to do the same thing. And these are the UVs. And then float to UV is gonna be UV's input vertex index. So it's just that. We don't need these special decorations on UV. Oh, no, we do. Text chord. Apparently we do. Or maybe we don't. I mean, it's not. What if we don't? Like these we need, because like we need to pass that in. But that just goes straight through in here, so presumably we don't need that. Of course, this needs to be text dim. This just needs to be divided by texture dimensions. And texture dimensions, they aren't even gonna change. So this can change. This is viewport dimensions, but texture dimensions never do change. Well, I guess we need another constant buffer then. Well, okay, so many things. So first we need a constant buffer with the viewport. But then we also need another one for text dim. Okay, so this one is immutable. We don't have any CPU access to that. But we need to supply initial data. Some resource data or something. Text dim is, well, I mean, it's 2.2 right now. I'm gonna have to change that. Compilation failed. Can you tell me why it failed? Can I have an error? There it is. Input parameter input missing semantics. Are you complaining of function return value missing semantics? Well, that is some vague error text code. Like, is that what you're looking for? Why? Why do I have to... Okay, well, there's no data here. It's just... that is the data. Of course, we're not done. Here, we've got more to do. We have to pass this in the... Alright. Yes, input. B2. Top left, bottom right. Yeah. Rect buffer. Yeah. Do I just supply some? Yeah, I do supply some initial data. Okay. Top left, bottom right, and then just texture dimensions. Top left 0, 0. Bottom right 2, 2. I mean, I guess it's gonna have to be in pixels. Well, it doesn't have to be. Yeah. So that'll be in pixels. Alright, so that goes in there. This we are calculating here. We need to bind the buffer correctly. Okay, VS set constant buffers. Okay, the first one has the... Well, actually, that one we only need to set once. We don't need to set it every time. I mean, I guess we could set it every time. but we don't have to. So we kind of need to do this when we create that constant buffer. Like right here. Can we just do that? And then never again? Does that mean we can release it here? Maybe. And then we don't need to keep it around. That's fine. Viewport, text dim, rect buffer. Okay. So we are setting now the other constant buffer needs to go into the other slot. That's VP dim. Yeah, viewport goes into the other slot. That should work. Sampler, we need a sampler. Okay, let's create a sampler. Okay, so create sampler state actually. And this is D3D sampler state. Device, create, rasterizer state sampler, device, description sampler. What's the description? Description is D3D11 sampler desk. So all these things. Filtering method to use. We want nearest. Point, I'm guessing, right? Min, mag, mip, point. address U, address mode, clamp. MIP load bias, offset from the calculated MIP map level. 0, I'm guessing. Max anisotropy. 1. Comparison func. Compare sample that exists against existing. Why would we need that? Less, equal, greater than equal. What? A function that compares sample data against existing sample data. What existing sample data? We're sampling a texture. What existing sample data are you talking about? What? Never? Border color. We don't need border color. Min load. We don't have any loads on this one. Let's see. Actually, we don't have to specify the comparison func. I mean, I guess 0 is also a valid value somehow. And max anisotropy. Wait, hold on. We're not specifying max anisotropy. Which means it will be set to 0, but valid between 1 and... so it's only if you've specified a filter that's anisotropy, okay. Okay, so that's what we need to do there with the sampler. Okay. So we're creating, now we need to bind the sampler, right? Set sampler. Match case. PS set samplers. Context LPV table PS set samplers. I mean, we have the one sampler, to be fair. Do we need to set it every time? Really? We don't have any other samplers. Can't we just set it here? PS samplers context 01 sampler. Like start slot, number of samplers, and pointer to. Okay. D3D11 sampler state pointer array samplers sampler context starting slot samplers length samplers pointer. Samplers, something like that. Cast uint. Oh, 1. Do we still need to cast? No. Okay. So we are setting the sampler. Now we also need to set the texture. I mean, we have the one texture. Can we just set it here? Context LPV table PS set texture. Where is it? Set textures. Set shader resource actually. Set shader resources. And then maybe we can just release it right there. Set shader resources, texture view. Well, actually, it's a whole thing. Texture resource view, right? It's this. Oh my god. Nope. Resource view array. Resources, texture view, and this is context. Start slot, resources, length, resources, pointer, something like that. So we have the one texture and the one sampler and the one buffer for the texture dimensions. So presumably we can just set it right here and not worry about it. Anything else? No, I think that's that. Yeah, I don't really know what this is gonna do. Alright, yeah, we didn't specify the description. So in here we have text top left and text bottom right. Yeah. And that's per instance. Why can't it just infer the length of the... Like, it clearly knows how much it... Even C can infer the length. Okay. Okay, no errors here, so that's a good start. Okay, let's see. Load last, launch, capture. Alright. Okay, so textures, like the data is being passed in. That's good. Do we have this VPDIM? Yes. Do we have TextDim? Yes. TextDim has also been set. Okay, what's UV? 0, 0. Yeah, that's fine. Okay. So vertex shader part is actually fine. Debug. Okay, what are we sampling there? Text. We sampled something. Oh yeah, so the alpha that we're looking for is it's in the A component of the texture. So the way we're gonna handle that is we're just gonna broadcast it. Yeah, like that. Alright, so are we upside down? Is that what I'm seeing here? Or is that not? No, the last, the top, but the bottom right is 255. We're good. Okay, well there it is. It's being sampled correctly. Alright, let's find out if we can just release, let's say, the sampler here. Apparently, yeah, we can. Once you set it, you don't need to keep the pointer around. Well, we don't need the texture view either. And we don't need this constant buffer. I mean, honestly, we don't even need like the rasterizer or the layout or the p-shape or the... We don't need a lot of this. Maybe we should just set it and release it. Or maybe not, because like if we want to extend it, then it'll be kind of annoying to extend it. But I mean, I'll just keep in mind that yeah, you can just do it that way. Actually, both of these. So that's pixel shader stage. Shader resources. Yeah, this texture we don't need. Let's see. Although yeah, let's just add that to the other one. Does that still work? Seemingly. Okay, so they aren't colored. But we are passing them in. Might as well color them. And that way we'll Okay, so also, I think it's pretty clear at this point that we don't need the max depth there. Also, we need to set the blend. So its color is gonna be like input color times text A. Yeah, whatever the input color is multiplied by alpha. So if it's white, it'll become like, and texture alpha is 0, it'll just be cleared to zeros. Actually, I think that's all we need. Or like that. And then we blend it. So whatever the input color is, set its alpha. So its alpha is gonna be just 1 most of the time. So most of the time we'll just be setting it to the texture level. Yeah. UV color, and we need to set it. Output color, input color. Float for color. Color. Should I just do a V4 or should I just leave color? Yeah. GBA. So this is gonna be that, just all white. It's gonna be red. It's such a waste of time, this having to specify this manually. Implicit truncation of vector type. Actually, in tasks, right, can we specify a problem matcher, which is like no. You have to define that manually. Okay, well. Actually, can we ask ChatGPT to just, like, generate a problem matcher for us here? Oh my god. Generate a VS Code problem matcher for this error message. Okay, so that. Does it work as is? Nope. Absolute. Nope. I mean, this is wrong. So, ChatGPT, not that good. Not that good at stuff. Any character, any number of, well, it's not really any character, right? It's not a bracket. Any number of times. Yeah, not a bracket, any number of times. Capture that, and then just do this. Well, both file and regex, like, if I can play around or something. Let's see. Okay, so we want like this regular. Oh my god, what is that? And the thing that we are matching is this. Wow, this is awful. What? Test string, regular expression. Why so bad? Is this white? No, this is not white mode. Okay, well that's good. Well, I mean, this did match group 1, match 1. This did match, yes. Okay, so that. Then we want then we want an open bracket, but it has to be like a literal open bracket. Open bracket. Then we want to capture a digit. I mean, this is a digit. But now we aren't matching anything. Anyway, so it's a digit, then it's a comma. Then it's a digit again. Then it's a dash. Then it's a digit again. Then it's a close parenthesis. Then it's a dot, and then colon, space. colon space that. Alright. So capture group 1, capture group 2, capture group 3, capture group 4. Okay, so this is it. Now we need to replace these with double. So it's file, line, column, and message. No? It's not, no, oh, it is. Alright. Here we go. Implicit truncation of vector type. Yes. So that's a float 4. Okay, very good. Is that enough, or did I? Alright, so we've got the yellow, and we've got a red. Interesting. What did we actually want? Well, that one is a red. That second one. The first one being a yellow, though, is weird. It's just all ones. Let's see what's happening there. Okay, well, let's see what's happening here. Draw instance. Okay, so we get the texture, which is like 0.3 or whatever. We get the color, which is just 1. Now we do the now we multiply the color by the texture there, and we get 1 here, which is what we want. Yeah, so it's not blending. We didn't set up the blend state, so it's not blending it, but it is just this. So for that whole rectangle, it's just gonna get that. Okay, that makes sense. Why is this yellow? We get the texture, which is whatever, 0.3. We get the color, 1101. Okay. Input. There is only 2 colors here. I mean 2 numbers. Why? Why is there only 2 numbers? It's a float 4. Also 2 instances, so how do we look at the other instance? Instance. to two num. Why is this a float 2? How is this a float 2? I don't get it. Let's see, input. Yeah. So input is a float 4, but also isn't. Is it like, did I set it to be a float 2 here somewhere or something? Struct color for floats. Wait, 1, 0. No, that's the red one. That's fine. That one's fine. No, we want specifically that first instance. Input, color. Why is that 0? Like everything else is fine, but that's 0 though. How did that happen? So first instance 1.901. Wait, did I in the description? No, description's fine. Color offset off. It's like it's using the wrong slot or something like that. Is input color offset off. Oh wait, format. There. Yeah. Okay, so now the only thing we need to do, that was done to doing, is blending. Where's the web browser? Here. Blend state. Okay, so you do that, just device LPV table, create blend state, device description, and return value. Okay, so it's D3D11, blend desk. Okay, well, so it's actually this thing that we kind of want to know. desk. Actually, can we do the C99 thing? It's like render target 0. Like, I don't think it'll let us just do that. I mean, this is an array, so can we do it this way? Yeah. An array of structs. Yeah. So really, we want to look at this thing, which is all this stuff. Blend enable, true. Source blend. D3D11 blend. Source alpha. Well, is it 0? Oh my god. Source alpha. The blend factor is that. That is alpha data from pixel shade. No pre-blend operation. Yeah, that seems like what we want. Dest blend. I don't think we need a dest blend. Oh, do we? Inf source alpha. The blend operation specifies the operation to perform on the current RGB value in the render target. Inf source alpha. The blend target is that. Okay, well, I mean, let's just try this. Blend op. The blend operation to perform, yeah. Add. Yeah, add. Describing like math using enums is so good. Blend alpha. Do we even need that? Blend alpha. It's this, which is different from source. Wait, source blend and source blend alpha. Oh yeah, because there might be different things you want to do to the alpha and to the rest of the, yeah. Now, so alpha just means like alpha times source plus 1 minus alpha times dest, right? Like, that's what we're trying to describe here? Yeah. Blend op alpha. And we just want to do the same for alpha and color. Render target right mask. Right enable all. A right mask. That. Okay, so we're not setting it, so it's not going to change anything. It's trying to use a blend that manipulates color, which is invalid. How so? How is it invalid? blend enable true. Blend source alpha. Blend in source. Oh, wait, source. In source color. In source alpha. There. Okay. No. We are getting rid of something. That blend. Yeah. Seemingly no errors. Now I just need to set the blend. Oh, it's output merger? Okay, OM set blend state. Okay, let's see what arguments this is supposed to take. Blend state, blend factor, and sample mask. The default value is that. I see. Blend state. What's this blend factor? Array of blend factors. Null. If you pass null, it'll just be all ones. Okay. Yeah. Yeah, that is what I expected to see. Well, probably. Let's actually check. Texture viewer, okay. So, well, we don't really care too much about what the alpha is. Well, the background is that 0.090 whatever, and this is 0.1. Okay, so this should be 1001. Yeah, and that is okay, so that is the alpha that we passed in. So we passed 200. Do we have? Yeah, so we passed 200. So 0.78 presumably. 0.83. Interesting. So that's the color. So if you look at our texture pixels, 10, 100, 200, 255. So 10, 100, 200, 255 divided by 255. So that's kind of what you expect. 0.03. 0.9. Well, it blended, right? So I mean, we could just go in and debug. 0.03. Okay, so we do seem to be passing in the correct thing. And then the color is just whatever sample, so that would be 1. So we just make it more like that, so we multiply the alpha, and then it will blend. And presumably when it blends, well, the bag is gonna do this much. Okay, so it's gonna be 0.039215, whatever. So that's the alpha times 1 plus, well, really this is like 10 over 255, right? Times 1 plus 1 minus 10 over 255 times the destination, which is the destination is what do we clear, whatever we are clearing it to, right, which is 0.1. Something like that. I think that's the blend that ends up happening, 0.13. Yes. Seems correct, right? And this one, 0.45. Well, that's just 100 on 255 times 1 minus that times this 0.45. Yeah, that seems correct. Yeah, this is just 1. Okay, 0.8. Well, let's just check it. Why not? 0.805. Yeah. It seems to be doing the blend that I expected to do. Okay, well, if that's the case, and we're not getting any errors, then I'm just gonna commit this. So we added 3 more things: texture, sampler, and blend. As well as this const buffer. So the actual texture is created down here. Yes, and we're releasing all this stuff. Map on map, whatever, right? Okay, so that seems fine. Alright. And all this stuff to do with blending. Well, and raw textured rects. Alright, yeah, we're good. Okay, so that's gonna be it for the day. See you later.